Welcome back, and let's continue with our application questions, where we are going to be looking at just more than one or two exponential laws in a question. So let's answer the following questions without the use of a calculator. We have there 4 squared multiplied by 4 raised to the exponent 6, and this is all divided by 4 raised to the exponent 5. So let us start with our multiplication. Remember, when we are multiplying the same base, then we are going to add the exponents. So we are going to say that is 4, and as an exponent we are going to say 2 plus 6. Why? Because they have the same base. So that means we are going to add the exponents, and this is divided by 4 to the exponent 5. Now 2 plus 6 is 8. So we have 4 exponent 8, and this is divided by 4 exponent 5. Now this brings us to another law, the one that we learned about dividing the same base. Remember, when we are dividing the same base, then we are going to subtract the exponents. So this is going to be 8 minus 5. And our answer there is going to be 4 to the exponent 3. But again, remember, because our 4 can be broken down further, we can say there that it is 2 to the exponent, 4 is 2 to the exponent 2. And this power is raised to the exponent 3. And then that comes now into another law of when a power is raised to an exponent. And what is going to happen to the exponents there? We are going to multiply the exponents. So that is going to give us 2, and 2 times 3 is going to be 6. So our final answer is going to be 2 raised to the exponent 6. Let's look at our second question here. We have 6 multiplied by 6 raised to the exponent 12 multiplied by 6 raised to the exponent 7. Now that 6 there does have an exponent 1, so we are going to add that as well. So we are going to keep the base, and because everything is being multiplied, we are going to add all the exponents. So we have 6 raised to the exponent 1 plus 12 plus 7. Do you know what 1 plus 12 plus 7 is? Yes, it is 6 to the exponent of 20. Now, remember that 6 can be broken down further to simplify our question, and that will give us a 2 multiplied by 3, because 2 multiplied by 3 is 6, and that product is raised to the exponent 20. What happens when we are raising a product to an exponent? It means that each factor is going to get the exponent. So that is going to be 2 raised to the exponent 20 multiplied by 3 raised to the exponent 20. Let's move on to the next example. Now we have a negative 10 raised to the exponent 3, and that power is raised to the exponent 2, divided by negative 10, and that is raised to the exponent 4. When we're looking at the numerator, we are going to say negative 10, and what's going to happen to our exponents? That is 3 multiplied by 2. This is divided by negative 10 raised to the exponent 4. When we apply our exponent laws, we are going to say, okay, that is negative 10 to the exponent 6 divided by negative 10 to the exponent 4. What happens when we are dividing the same base? We are going to subtract the exponents, and then 6 minus 4 is going to be 2. And that is our answer for that question. Let's move on to the next example. Now we have 6 raised to the exponent 3, and that power is raised to the exponent 4. We are going to divide that by 6 raised to the exponent 12. What happens when we are raising a power to a given exponent? Yes, we are going to multiply the exponents. So that is going to be 3 multiplied by 4. And we are dividing this by 6 raised to the exponent 12. What is 3 times 4? Yes, it is 12. So now we have 6 raised to the exponent 12 divided by 6 raised to an exponent 12. We have a power that is the same, and we are dividing it by a power that is the same. So do you remember what happens when we are dividing the same number by itself? That takes us back to the properties of 1, and that is going to give us an answer of 1. Let's move on to the next example, where we have 2 raised to the exponent 9 divided by 2 raised to the exponent 4 multiplied by 2 squared. Now, you have to be careful with this one because we are dividing and multiplying. So don't confuse your exponent laws. So we are going to start by dividing. Remember what happens when we are dividing powers of the same base. We are going to keep the base and we are going to subtract the exponents. So that is going to be 9 minus 4. And we are still going to multiply by the 2 squared. And 9 minus 4 is going to give us an exponent of 5. Then we are going to multiply with the 2 squared. And do you remember what happens when we are multiplying powers of the same base? Yes, you are correct. We are going to add the exponents. So that is 5 plus 2, and that is going to give us an answer of 2 to the exponent of 7. Our next example, I know it looks complicated, but it really isn't. Let's look at the products. We have 3 multiplied by 2 raised to the exponent 14, divided by 2 multiplied by 3 raised to exponent 3, multiplied by 3 multiplied by 2 raised to the exponent 7. So remember that multiplication is commutative. So it means that I can swap the factors around. So just to accommodate all of them, we have 3 multiplied by 2 there, we have 3 multiplied by 2 there, and there we have 2 multiplied by 3. So to avoid confusion, you can just swap it around. So I have 3 multiplied by 2 raised to the exponent 14, and that is 3 multiplied by 2 raised to the exponent 3 multiplied by, again, 3 multiplied by 2 raised to the exponent 7. Now, if you look carefully, we have the same base. So our base here will be the product of 3 and 2. So because we have the same base, what do our exponent laws say? Our exponent law says that we are going to add the exponents. So we are going to keep the base. So our base is 3 times 2. And then we are going to add the exponents. And then that is going to give us an exponent of 10. So, us having the same base, now what is going to happen? Again, we are dividing the same base. What happens when we are dividing the same base? We are going to subtract the exponents. So this is going to be 3 multiplied by 2, and then we are going to subtract the exponents, that is 14 minus 10, and that gives us 4. And as a final answer, again, applying our exponent laws, that is going to give us 3 to the exponent 4 multiplied by 2 to the exponent 4. Let's move on to the next question. So we have there 4 to the exponent 9 multiplied by 4 to the exponent 4. And this product is raised to the exponent 1. And then this is all divided by 4 squared. So remember, we have powers of the same base. So what happens when we have powers of the same base? We are going to add the exponents. So I am going to keep this base 4 and I'm going to add the exponents. And remember, this is raised to the exponent 1. We are going to divide this by 4 squared. Then I have 4 what is 9 plus 4? That will give us 13 raised to the exponent 1 divided by 4 squared. When we apply our exponent laws, when a power is raised to an exponent, we are going to multiply the 13 and the 1. But 13 multiplied by 1 still gives us 13. We are dividing that by 4 squared. And what happens when we are dividing powers that have the same base? We are going to subtract the exponents. So that gives us 4, and 13 minus 2 gives us an exponent of 11. Let's go to the next example. We have 12 raised to the exponent 3, and that power is raised to the exponent 2, divided by 12 raised to the exponent 4. So let's apply our exponent laws there. When we have a power raised to an exponent, we are going to say 12, and that is 3 multiplied by 2. That is divided by 12 raised to the exponent 4. We have an answer of, what is 3 times 2? That is 6, divided by 12 to the exponent 4. And then that will give us 12 to the exponent 6 minus 4. And our answer there is going to be 12 to the exponent 2. And of course, as you've seen, we can break it down further. But that is our answer for that question. Let's go to an ad break, and then we'll see you just now.